All right, let's talk about how to do this practice assessment for these last two short learning targets. The learning targets that are covered are I can explain the concept of a mole in terms of chemistry and how it relates to the atomic masses listed on the periodic table. And I can use dimensional analysis to convert units from one to another, like grams to moles and moles to grams. All right, question one. 1 mole of helium has a mass of about what? Well, 1 mole of helium on the periodic table, the bottom number tells you how much 1 mole of helium atoms would weigh. So again, 1 mole of helium atoms is equal to 6.02 times 10 to the 23rd atoms, which for helium is equal to about 4 grams. So the answer for number 1 is 4 grams. What's the molar mass for the following? Calcium. Calcium's number 20. Its molar mass is 40.08. And the units are grams per mole. And for oxygen, it's 16 grams per mole. Magnesium is 24.305. Fluorine is 19. Again, we're just looking up the squares. And then now it's asking us to add some elements together. So calcium is 40.08 from above plus 2 fluorines. So 2 times 19. So I'm going to go to my calculator on my phone and do 2 times 19 plus 40.08, 78.08. A lot of people will ask about rounding the molar masses, and I would say just don't round as often as you can. There are exceptions, like oxygen is like 15.999 something. Okay, same with fluorine. So yeah, but just don't make it a habit to start rounding. Otherwise, you kind of get carried away and then numbers get to be really off. All right, how about MgO? So Mg, we can see from above, is 24.305 plus oxygen is 16. So in my phone, I'm adding that together, 40.305 grams per mole. And there's kind of a longer random last one. Let's see, Na is 22.99. Hydrogen is 1.008. Carbon is 12.01. And oxygen is 16 times 3 of them. So I'm going to type this in my phone. 16 times 3 plus 1.008 plus 12.01 plus 22.99. Answer, 84.008 grams per mole. All right. What if you've got 40 grams of a piece of iron? How many moles is that? Well, we want grams of iron to cancel out, and we want it to convert into moles of iron. So we want grams to be on the bottom so that those units cancel out. But we need to set up a conversion. We know 1 mole of iron is equal to 55.85 on the periodic table. And then we want to multiply across the top and divide by the bottom to get our final answer. So 40 divided by 55.85, answer 0.7 moles of iron. What if you scraped 0.35 moles of rust, which is iron 3 oxide, off of some rusty nails? Oops, Fe2O3. We've got to figure out how much does 1 mole of Fe2O3 weigh. So we've got to go to the periodic table and add this up. We had iron in the last question, so we know it's 55.85 times 2 plus oxygen is 16 times 3. So 55.85 times 2 plus 48, because that's 16 times 3, 159.7 grams of iron oxide. That's how much 1 mole's worth of that molecule weighs. So what if you don't have a mole? You have 0.35 of a mole, 35% of the mole. How do you figure that out? So we're going to do 0.35 times 159.7, because it's multiply across the top. Answer, 55 point, I'm going to round this to 55.9 grams of Fe2O3. Yes, I know it's tedious to always be writing out these chemicals in the units, but that is part of it. All right, you've got 2,000 grams of octane, C8H18. How many moles is that? Well, we need to figure out how much 1 mole of C8H18 weighs. So let's go to the periodic table. Carbon weighs 12.01, and there's 8 carbons, plus hydrogen weighs 1.008, and there are 18 of them. So let's see. I get a total of 114.224 grams of C8H18. So now I have to do that times 2,000, because those are both on the top. And I would have 2,000. Oh, look what I did. My units don't cancel out. Grams squared over moles. Oh, I must have made a mistake. Thank goodness for dimensional analysis. So I want 1 mole of C8H18 on the top, and I want that, oh goodness, now I forgot to write it down. It's good that I'm making this mistake though, because this is very common for students. And then I'll explain again how you know that you're right. I just noticed that my units weren't canceling out. So grams of C8H18 are on the top and the bottom. So those cancel out, and then I'm left with moles, which is what the question is asking for. So I need to do 2,000 times 1 divided by 114.224 to get my final answer, which is 17.5 moles of C8H18. Otherwise, if I left it the other way, I would have ended up with units of grams squared over moles, which makes no sense. There's like no use for those units ever. All right, number 6. We've got 2.5 moles of NaOH. We're making homemade soap. How many grams do we need of sodium hydroxide? All right, well, how much does 1 mole of NaOH weigh? Blank grams of NaOH. Okay, we need to go to the periodic table and add this up. So we've got 22.99 plus 16 plus 1.008. So I'm going to my phone to add this up. And it's about 40. It's like 39.998. At that point, you can round. So then 40 times 2.5, answer 100 grams of NaOH. And you might have gotten this feeling already that, like, you know, rounding differently is not going to mean that you get the question wrong. The setup is what's most important. Okay, one more question. Which has more atoms, 10 grams of barium or 10 grams of magnesium? Well, let's look at their molar masses. Barium has a large molar mass, 137.33. And magnesium is 24.305. So magnesium atoms are smaller. So let me ask you this. If I had 10 grams of rocks and I had 10 grams of pebbles, like tiny rocks, which one has more pieces? We would say the pebbles because they're smaller, so it must take more of them to have the same mass. So with these two atoms, barium atoms are larger than magnesium, so that must mean that magnesium atoms, or this sample of magnesium has more atoms because the atoms are smaller, so it takes more of them to equal 10 grams. If you want to back it up with math, you certainly can. It's just a little bit more work. So 10 grams of barium, 1 mole of barium atoms contains or weighs 137.33 grams. And then let's keep it going. We know that 1 mole of barium has 6.02 times 10 to the 23rd atoms. Okay, and then we're going to do the same setup for magnesium. 10 grams of magnesium, 1 mole of magnesium weighs 24.305 grams, and 1 mole of magnesium contains 6.02 times 10 to the 23rd atoms. Okay, so multiply across the top, divide by the bottom to figure out which one has the most atoms. So we can do this in Google. 10 times 6.02 times 10 to the 23rd divided by 137.33. Is that right? 137.33 equals, come on, Google, 4.38 times 10 to the 22nd. Now let's do the other one. 10 times 6.02 times 10 to the 23rd divided by 24.305. 2.48 times 10 to the 23rd. So we were right. Oops, I should have labeled these with the chemical symbol too. So the 10 grams of magnesium contains more atoms. So again, if you like math, you can certainly do it that way, or you can just explain with like, okay, it's a smaller atom, so the 10 grams of magnesium would contain more. So hopefully that helps you out. Again, practice makes perfect with the dimensional analysis. Good job.